So an AWS account has been hacked and it's our job to find out how it happened. We're going to be using Amazon Athena and AWS CloudTrail logs to find out how it exactly happened. Let me share my screen. Let's get started. Basically, on this episode, we're going through the defender's path of Flaws2.cloud. You can check the attacker's path up there. There's a playlist for it. I'm going to add this video to that playlist too. So we're going to come to the end of Flaws2.cloud series, basically. And in this defender's path, there is basically like 6 objectives that we need to achieve. We're going to be using Amazon Athena and AWS CloudTrail logs. In the objective itself, if you follow them, is using JQ, but I thought it would be better to use like Amazon Athena and CloudTrail logs because it's more realistic to real-life incident response. Although in the real-life incident response, you're going to be using some beefed-up SIEM like Splunk, but still I thought it's closer to real-life. CloudTrail logs is basically a service that keeps track of all the API calls that happens within your AWS. And every event on AWS is actually an API call, so you can get a clear image of what happened and puts it all in an S3 bucket. Amazon Athena is basically a serverless SQL querying service, which you can query the logs which sit on an S3 bucket using SQL. So it's kind of close to a real life scenario. So let's look at the scenario and get started with this. We have 2 accounts here. One is the security account and one is the target account that the incident actually happened in. In real life scenarios, or most companies, as a best practice, have these 2 accounts separated. And you might ask why? Because we want our logs and security tooling to be separated from the hacked, where the incident happened account. So in this scenario is the target account and we want the security account to be separated, right? So when we have it separated, this user, the security user here, can assume the role and go to the target account, and we can check the logs, or we can just check the policies on there and everything. So first thing we want to do is that to create that security account, and then we can configure the role so we can use the role as well. So for that, I'm just going to go to my terminal and I'll make sure it's zoomed in so you can see properly. I'm going to use AWS configure -- profile, and we're going to call this profile security. That's our first profile that we're creating. And it wants the access ID, access key actually, which is right here. I'm going to copy that one, paste it right there. Next thing it needs is secret key, which I'll be copying from here and paste it right there. For now, no region, and the output doesn't have to be there, so it's fine. So now we have the security account set up. We want to set up the target account, and it's this tab right here. We set it up, the role and everything that we're going to be assuming using our security profile. So for that, I'm going to be doing nano.aws config. And in here, I want to set up that security and also target security account roles. But as we can see, we do have the region. So I'm going to paste the region for the security account. And for this configuration, I just have to copy this basically for the target security and the role underneath of it that we need to assume. So for this, I'm going to exit, make sure that I'm saving it. Actually, now it's showing properly. Make sure I'm saving it, exit, and it's done properly. For me to test if we can actually assume that role from our security account, I'm going to do AWS profile, can't type, profile target _ security, and we're going to do sts get caller identity. Let's see what it comes back with. So yes, here it is. So we can assume it that it's a good sign. That means that we have done our configurations right. Next thing we need to do is we need to create the logs basically on AWS, on Amazon Athena. We need to create the table and the database for us to be able to query the logs in there. And for that, the instructions for it is actually on Objective 6 on using Athena. The reason we're jumping to Objective 6 is that 1 to 5 is basically using JCube, but we want to use Athena for all of it. So that's why we're doing this. And it has given us the command for this, create the database, and also this is the command for creating the table. So what I'm going to do is that I'm going to use the same command, which I've pre-written here, so you don't have to be bored with me copy-pasting commands or trying to write commands in here. By commands, I mean SQL queries. So let's do it. We're going to create a database first. So I'm going to run that command. We're going to create a database. Query successful. We created the database. We're calling it Flaws2. And then we want to create a table called CloudTrail. And you can see this query is a long one, but I didn't write that. I basically got it from Flaws2.cloud. You can just copy paste that into your Amazon Athena and you have it. And it's basically getting the logs from a remote S3 bucket and it's creating a table with it. So let's do that as well. And query successful. So now we have the database. And we also do have the table. What we want to do is that we want to query it to get the information to see the timeline of what actually happened. So this is what the timeline query is for actually. Again, I don't want to type it out in front of you, so I'm just going to go through what this SQL is doing. So it's going to give us columns like events events time, because we want to know the timeline of when things actually happened. And source IP is important for us to see if it's an AWS IP or if it's outside of AWS. This thing is happening, if we trust the IP or not. And the user identity ARN, basically the user address, I'm just going to be calling it user ARN. And the account ID of the user, again, it's important for us to know if the account ID is within AWS or within our AWS account or within another AWS account that is coming from. Identity type, event source, event name, those are the information that we need as well. Event name is important because we want to know what event is actually taking place. And all of these, we're bringing it from the table that is called CloudTrail, which we created earlier with the query before this. And the type of user, we're putting a filter here, basically. We're saying we don't want it to be AWS accounts or anonymous. So what we're trying to achieve with this is that we want to get only real user-driven events and not all the other events that might happen on AWS. So we can exactly see what the users have done in here. And all of this, we want to order it by time from the beginning to the end. We want to see what happened. So I'm going to run that query and it's going to give us back this table. Pretty much it has everything we needed. Event time, so it starts like somewhere at 10:30 at night and it goes on until 11:10. The source IP we can see, and all the other columns we asked for, the user on the user basically address, account ID, which account it happened from what we can see is all from the same account, the type of event that happened, the source, and the event name. So all the interesting data in here. Some of the things that we look at this and it stands out to us is that these final events has happened from the source IP that is outside of AWS. What do I mean by that? This IP, it does not belong to AWS. And that's not always a red flag. They could be using a CLI or whatever, but it could be a red flag sometimes. But the rest of these we can see it's using AWS IP address. If you want to know AWS IP addresses, I'll include this link on the description so you can know about AWS IP addresses. Usually I just ask ChatGPT as well if it's AWS IP or not. So this, it seems like it's not from an AWS IP. The one that in the logs that has our attention is this on right here, which is the address of level 3 role, which was assumed, right? And it did like a list bucket. Before that, it's kind of weird too, because it's trying, it depending on your environment, it could be weird or not. It's doing get download URL for layer. So that's a pretty uncommon event, I would say. But depending on your environment, it might be common for it to happen. So why is it trying to get our Docker image layers? That's a question. But a bigger question is that this role right here, it seems like this has a session ID at the end of it. So it looks like a temporary role that was supposed to be used by an AWS service. And if it's supposed to be used by an AWS service, why is it coming from a non-AWS IP address? So that's a big question that we have right here. So for us to be clarified on that, I also need to clarify, is this role only supposed to be used by an AWS service or not? So for me to be clarified on that, I want to know about the policy that is being used on here on level 3. So for that, I'm going to go back to my command line and I'm going to run this query to find out more about the IAM policy of that role, right? So I'm going to do profile -- profile and target underscore security. And I'm going to do IAM get role and then -- role name for the role that we're doing, basically, which is level 3. Okay, so let's see what it comes back with. Basically, we want to understand the policy better. So there's some interesting things in policy right away, like the description of it, right? It says allow ECS tasks to call AWS services on your behalf. So what is supposed to be using this role? ECS, okay? The description says that. But also, the principal that is supposed to be using this role is supposed to be ECS tasks. So ECS is supposed to be using this role. However, the IP that is using this role is not an AWS IP, is not an ECS related IP. So this right here is kind of giving away to us that someone got access to these temporary credentials that was supposed to be used by only an AWS service. Okay, so that's interesting. That happened. So we know the AWS credentials are potentially stolen. So we want to see before that how it was exactly stolen, where this whole thing started about this ECS, and how did they get access to this image. So for this part, we can see they did get images and get batch image and also get download URL. And before that, it's just list objects on a S3 bucket. So it has nothing to do with an ECS service. But list images, it does have to do something with ECS. I want to know the name of this ECS that was used. So what was that ECS that was used to do list images right before the credentials were potentially stolen? So for that, I want to find the repo name. And I used a query that was basically I got from ChatGPT, and I was like, where the name is like list users, I want to know the repository name. What repository name was called out here for listing images? So I'm going to run that query, see what it comes back with. And we can see level 2. That's the repository name that was used. So what's interesting to us is that this was potentially what was open to them to use and the credentials that they got from here, right? So what I want to do is I'll do like a clear on this one. Clear. So we'll go back on top of the screen. I want to read the policy that is regarding this level 2 repository, like if the policy looks correct or not, if there is something dodgy about the policy of this repository. Is it locked down enough within our AWS account or not? So I'm going to AWS -- profile target underscore security and ECR get repository policy. That's what we're looking for, the policy, and dash repository name level 2. So over here, we are trying to get level 2 repository, the policy that is attached to it. Let's see what we get. It doesn't look good, but if you want to make it look better, you can use JQ. But because it's a short policy, I can already see what I'm looking for. And what stands out to us is because we want to see if another user from outside of AWS had access to this or not. And what can we see here? Principal star. That is a wild card right there. That means it's open to the internet. So anyone on the internet could access the credentials of this repository. So that is a big red flag. This policy is not supposed to be like this. There is no explanation that this policy should be like this. The principal should be usually a specific role or a user, or it should just be ECS, ECR itself. It shouldn't be open like this to the world to be able to request access, to be able to do get URL or all the other things they can do. So that is a big red flag. And that is where potentially the attacker has gotten in and has been able to take over the ECS or ECR. And with that, whatever that ECS or ECR has access to, whatever that repository has access to, they basically have access to. So this is where the problem was, and this is where they got it. Thank you guys so much for watching. This is the end of our Flaws2.cloud series. In the future videos, I'm going to try to do more like engineering side of things. We've done Defender, we've done Attacker, and I want to show you more of like engineering side of things. So potentially create like a CI/CD pipeline properly using OpenID Connect and AWS. I think that would be a good idea to do. Thank you guys so much for watching. Subscribe if you want more content like this, and see you on the next one.